All right. We're at the bottom of the hour, and looks like we're getting a pretty good group. Wow, this is great. So we're on second day. You guys have to be pretty well maxed out at this point. Is anybody maxed out yet on information? What are you doing here?
Keep it coming.
Keep it coming. Okay, good. I like that. Awesome. Well, came here for dependency injection. Good. I'm glad. You're in the right place. Awesome. Well, my name is Secrist, as it says. I'm one of several technical trainers for Pivotal that are here at the conference. If you stop by our training area, you might have met some of them. If you haven't, stop by and say hi to some of the guys. If you have any training questions, feel free to fire them in. That's what we're here for. The goal of this session is to take you a little bit beyond dependency injection. How many people have heard the statement, Spring is just a dependency injection container? Anybody? How many think it's just a dependency injection container? How many think it's more? Awesome, great. Well, we're done then. See ya. Mission accomplished. All right, so my goal really is for those of you that might be wanting to know, okay, so what are some of the things you could do? I imagine some of you were here for Jürgen's talk earlier. He went into a few of those kinds of things that are kind of more than just what you can do with dependency injection. So that's the goal of this session, is to take us a little beyond. I'll get into a little more about that here in a second. A little bit about me. I've been in the development space for a few years, and I've done a couple of different languages, including C and C++, Java, and Enterprise Java, and so forth. I've actually bounced a little bit back and forth. I'm kind of schizophrenic when it comes to do I prefer to be just a developer, or do I like to be out amongst folks like this, kind of sharing the result of some of the experiences that I've had and so forth. And so I've kind of gone back and forth, and as you can see, I spent a little bit of time as sort of a consultant evangelist at HP, talking about Java and Enterprise Java on the HP platform. That was a number of years ago. Back in development again, doing Spring-based development and that sort of thing, and then more recently as a technical trainer for VMware and now Pivotal. So some of the classes that I teach are Core Spring, Spring Web, Groovy and Grails, Gemfire class, and one of our new classes, a Big Data, Hadoop, and Pivotal HD class. So that one's on its way out. We'll have that one probably ready to go publicly in the next month or so. All right. So enough about me. What are we going to cover in this session? The goal is, first of all, I want to give you a little bit of an overview of the life cycle of what really happens inside of Spring. Let me ask this question. How many people, has anybody been to a Spring training class? Anybody? A couple of you. Okay. Spring 3.0? A few of you? Okay. Some of you maybe older classes, pre-Spring 3.0, like a 2.5 class or something like that? All right. Well, the message you might have gotten is probably the same. So this will be a little bit of a refresher for you. One of the key things that I find when I talk to a lot of students, especially those that have been developing for a period of time, is that they have gotten kind of entrenched in their way of doing things. They've maybe learned how to do Spring development by looking at code examples on blogs, or they've read a good book, maybe Craig Wall's book, or the Spring Recipes book from Josh Long. And they've kind of learned how to do a few things, but they never really totally understood. So what happens inside of Spring? So when I start up Spring, what's all the magic that happens that makes transactions take place, and this thing and that thing? So I love to do this section on the lifecycle because it helps kind of expose some of the inner workings of Spring and take some of the mystery out of what actually happens. And the reason I'm bringing it up here is because really, there are a couple of patterns that we're going to go into, including programming to interfaces, proxies, AOP, and templates. But really at the heart and soul of all of that, and how Spring is able to do a lot of that, is through the centralized lifecycle. So while Spring is not just dependency injection and the centralized lifecycle is really a key part of how Spring does a lot of what it does. All right? So my goal here is to help you understand how Spring leverages these patterns, so how they make use of them, but more importantly, how can you make use of them yourselves? Okay, so hopefully you walk out of here with some good ideas of some different things that you might not have considered in the past that you might now be able to take back to your workplace and begin employing in your projects. So here's how we're going to get here. What I'll do is go through a number of steps, and we're going to first introduce the concept. So I'm going to kind of lay out what's the concept, lifecycle, what's the concept, interface, programming to interfaces. Then I'm going to show you some examples of where Spring makes use of that. And then what I'm going to do is talk a little more detail about, well, what might you be able to do with that same basic approach? So hopefully that just sparks some ideas, and we'll try and keep it a little bit interactive. So we'll have several sections. I'll present some concepts, and we'll, like I said, showcase some pieces in Spring, and then I'll demonstrate some code examples of some things that you could do, and then you can go ahead and fire questions into me. Now, excuse me, those of you that have been to a class, you're going to see that this feels a little bit like class. Like a class you've been to, and some of the material might actually look familiar. I actually freely borrowed material from our core class. We call that reuse. And I did that for a couple of purposes. For those of you that haven't been to education, hopefully it will maybe inspire you to consider taking a class, but there's a lot of really good material in there. And so what I've done is just kind of borrowed some of those slides and then added to it to help illustrate the points we've made. And so I hope in the process you get a flavor for the kinds of things you might get from a 4-day class, but I really do want you to walk away with some really good nuggets of some different tips and tricks that you can make use of from within Spring. All right, so let's talk about the life cycle. So how many people build Spring applications using XML configuration? Most of you? Is anybody doing other approaches, annotation-based approach, Java config? Okay, so if you have picked up anything from this conference this year and even last year, it's probably that the direction things are heading is Java configuration, right? So I show XML a lot of times because it's sometimes easier to illustrate the concepts using XML. It's very kind of verbose and easy to kind of take a look at the concepts and see how the pieces work. But I'm also going to try and show you some cases of using Java configuration and annotation-based configuration. And so is that new to anybody, any of those three approaches? Okay, maybe a little bit. XML, though, you're pretty comfortable with XML? Okay, so hopefully we can tie the pieces together, and in the process, you'll pick up a little bit about Java configuration and annotation. Yes, sir?
Will you go into detail why Java config is superior to XML, or is that something that should take offline?
Let's take that offline. I'm happy to have that conversation. There's lots of different thoughts about that, but yeah, I think we'll take that offline, and I'm happy to answer that question. Okay? So let's break down what's going on here in this XML file. In a typical core Spring class, I like to tell people that there's usually, this is what we call our configuration instructions. So I like to tell the students that there's at least 3 key things that are being communicated in this file as far as telling the application context how to behave, how to actually operate on this set of configuration instructions. Number 1, what class to instantiate. You guys can see that right up here. We have a class at the top, com.acme.transferServiceImpl, com.acme.jdbc account repository. So we're actually describing what specific class instance implementation will I instantiate. Number 2, what name to call it. Now that's not obligatory. It's an optional attribute, but it makes it very easy to refer to a bean by its name or its ID. Okay, so what class to instantiate, what name to call it, and the third thing is what are its dependencies and how are those dependencies connected. So what's the dependency for the transfer service impl? Account repository. How do we inject that dependency? By way of a constructor argument. So while very verbose, it's also very readable. You can look at this and get a pretty good idea of how things are hooked together. And we can see that transfer service impl has a dependency on account repository. Account repository has a dependency on data source, and so forth. Okay? So far, so good? All right, great. So the next thing we do is we take that XML file and we supply it as an argument to one of several application contexts. In this case, we're using an application context called the ClassPath XML application context. Now, you can kind of get an idea from reading the class name what that thing does. ClassPath reads the XML file from the ClassPath. XML probably reads an XML file. Application context. It's one of those application contexts. That is the thing, the dependency injection container, the thing that manages the lifecycle, that instantiates all the beans and does all the stuff we're going to talk about. Okay, so that's the heart and soul of this whole thing. That's how Spring kind of starts everything up. It's one of several ways. Okay, now you instantiate an application context, and then somewhere along the way you're going to perform a getBean operation. In that getBean operation, you're going to refer to typically a bean by its name. Now there's some new arguments that are available as of Spring 3 where you can ask for a bean by its type and so forth. Now in this case, we have asked for a bean of type transfer service. But wait a minute. What did we instantiate here as our class? Transfer service impl. I'm going to come back to this point a little bit later, but it's usually always a good idea when you're doing your casting to cast as the interface type. It's going to become very important, and you'll start seeing why a little bit later, but I just want to put that little placeholder in right now that we have actually cast that bean not as transfer service impl, but transfer service. Now, in this particular case, with everything we're seeing, we could have done that. We could have cast it to transfer service impl. But as we start working on programming to interfaces and taking advantage of some of the other features of Spring, we're going to find it to be more important that we cast to the interface. And you'll see why shortly. Okay? So we instantiate the application context, we do a getBean, we perform an operation on it, and from this point on, we're using the application as it's designed. So at that point, we're just interacting with objects in a very typical Java way, right? Pretty straightforward. Now, of course, the Java configuration way to do this is that I would have a class that I could call pretty much anything I want. I annotate the class with that configuration. I have a couple of bean methods that I declare at bean. I can optionally specify a bean name. If I don't specify the bean name, by default, we would use the method name. Okay, so in the case of the transfer service method, I wouldn't have to call it transfer service. I wouldn't have to pass the string into the bean because the method name is called transfer service. But if I wanted to have a method name that was decoupled or different than the name of the bean I want to refer to it, then I would typically provide that argument. So what I've done here is a very quick and easy instantiate the transfer service, call the setter, return the object, and so forth. Now, just to answer your question really quick about what might be better about this, it's Java, it's got strong typing, and more importantly, I have full access to the entire Java API. So that means I can do anything I want inside of that bean creation method. That's probably, in a nutshell, the single biggest reason why Java configuration can be better. Now, I'm not saying it's always better in every case, but it does have some compelling arguments for that particular case. Okay? All right, now a slight difference here. There's a couple of different ways I can access the Java configuration approach. If you want to go with a pure Java configuration approach, we can simply instantiate a different application context, in this case called annotation config application context, in which case I pass it not an XML file, but I pass it a Java configuration class. That is this class right here. And then I basically get the same result. Okay, any questions about that? Yes?
Why did you center
I wanted to illustrate basically the discrete steps. There's a whole separate discussion about are setter injection better than constructors, and that's really not a Spring question, it's more of a Java question. And if you favor constructor injection, you can certainly do that. If you favor setter injection or property injection, you can do that and you can mix and match them in Spring. So I tend to like to dispel that one pretty quickly in classes. We support both approaches. Again, it's not a Spring question. It's really more of a what's a better pattern or better approach in Java. And just realize that whichever approach you take, you're able to do that freely in Spring. Okay? All right, so just to review, if we make this a little more complex and say that, for example, we have 2 XML files, and in those 2 XML files, I have some set of bean definitions, and I pass those as arguments to the application context, then some kind of bean instantiation takes place. But the question is, what really happens? So here's where we get into the real lifecycle discussion. What's going to happen as this instantiation process takes place? Well, let's take a look at that. First thing that's going to happen is that the bean definitions will get loaded. If it's XML, we're going to read XML file, and we're going to parse that XML syntax and figure out those instructions: what class to instantiate, what bean name to call it, and what dependencies there are. Next, we're going to go through a step that is called post-processing the bean definitions. Okay? Anybody know what the actual object that does that kind of work? Quick quiz. Anybody that's been to a spring class? Close. I heard bean post-processor. Bean factory post-processor. This is going to spark a little bit of a competition here, but I got a few prizes that I brought for people that just to provoke some audience participation. So I've got a little 8 gig USB here for you. Come up and get it after the class, okay? Or if you want to make your way up here and just come get it, that's fine too. Okay, it's called a bean factory post-processor. We're going to get into that here in a second. What does that actually do? What capability does it give you? And why might you want to use it yourself? Now, once the post-process bean definition step has taken place, then for each bean that has been loaded, we're going to go through a series of steps where we instantiate the beans and call their appropriate setters. Then we're going to go through a block that is called the bean post-processor. And some different things can take place there. What's the biggest difference between the bean factory post-processor and the bean post-processor? 2 key things. Number 1, bean factory post-processor operates on bean definitions before the beans get instantiated. They're reading and manipulating the bean definitions that will ultimately determine what those actual objects look like at instantiation time. Okay, so that's number 1. Number 2, bean factory post-processors operate on the entire bean factory. So everything that's in the bean factory, that happens in one operation, where the entire bean factory, the container for all of the bean definitions, that gets passed to a bean factory post-processor where you can iterate through the bean definitions looking for certain characteristics and patterns and change those definitions pre-instantiation. By difference here, what bean post-processors do is they operate on one bean at a time. Now we're going to go through a demonstration here shortly where I'll show you exactly what's going on. Okay? So bean post-processors operate on objects that are already instantiated. And there's actually 3 intermediate steps that take place throughout that bean post-processing step. And we're going to basically explode that in a little more detail when we get into that phase. Okay? Any questions on that life cycle so far? Okay? Essentially, at that point, once it's gone through that step, that particular bean's ready to use. But we have to iterate over the entire list. All of the beans that have been declared in the bean definition, they will go through the instantiate setters, go through the bean post-processing phase, and then that bean's ready to use. Once we've completed the instantiation of all those objects, then all of the objects, the application context instantiation process returns, and now I can perform operations like get bean, invoke the methods, and so forth. Okay? Yes, sir? Is there a difference when lazy is used? Yes. In fact, there is. I usually, in the course material, we actually have a step where we talk about that, and since you asked, I'll address it briefly. What essentially lazy instantiation does is that it takes everything that is in the second box, the for each bean. If that bean has been declared to be lazy, then it essentially is not instantiated, setters called, or any of the bean post-processors called until the first time it's referenced. So it just means wait to instantiate it until we really know if we need it. Okay? Now, it can appear to have some advantages. So you have 1,000, I had a customer that had something like 7,000, 8,000 beans that they were instantiating. Can you imagine the startup time on all of those? What if some percentage, half of those beans, weren't going to be used until later? you could improve the startup time by delaying the instantiation and the bean post-processing. So it does have an advantage. The trap that you fall into is that you might just be pushing or extending your response times throughout the life cycle of your application, which would degrade the performance of the application. So it does have some advantages, but also potentially pitfalls. But that's essentially what that does. Yes, sir? Yeah, so I think if I understand your point, what you're saying is that you can declare a bean to be lazy instantiated, but if it's referred to by a bean that's not lazy, then by inference, even though you declared it lazy, it's going to be instantiated right away anyway because the bean that referred to it is not lazy. So that's absolutely true. Yes, sir?
Just as an extension to that question, you could also lazily instantiate a bean based on certain conditions, right? I mean, in a certain environment, I might need this particular bean, but in another environment, I might not need that bean. So will this step take care of all that?
Well, there's a couple of ways to solve that problem. As of Spring 3.1, the best way to take care of that is using profiles. And you would use a profile to say that in this profile, when this profile is active, then you would have the dash lazy enabled and this profile not. So that would be the simplest way to do it now. Yep. Yes, sir. One more question.
In case of an annotation-based versus XML-based, do you think it's a performance hit on the annotation-based just because you have to go to figure out which beans have which annotations versus an XML file where you predefine, you know what configurations you're looking at?
Okay, so I'm going to try and see if I understand your question. The question is really, is there some kind of performance difference at startup between parsing that information if it's an annotation-based configuration versus XML? Possibly. I don't think it's going to be significant. Annotation-based typically would make use of things like component scanning. So you'd have to, startup time would depend somewhat on how broadly you declare your base package to scan, if you know what I'm talking about. So I mean, if you said scan everything in COM, then it's going to look in all your jar files everywhere, right? And that's going to take a lot of time. But if you specifically scope your search, it probably wouldn't significantly increase your startup time just using annotations. But again, that's just a startup time performance. It's not runtime. Yes, sir. One last. Is there a way to start the application context asynchronously? Sure. I mean, there's presumably. I mean, yeah, we'd have to take a look at kind of the architecture and at what point will you expect to have your beans available, because if you do it asynchronously, you have to have some way to know when has it succeeded in finishing and starting up, and more importantly, what happens if a startup fails. So, yeah, you probably could come up with an architecture, but you'd have to think that through pretty carefully. Yep. All right, let's move on. All right, so loading the bean definitions. Now, bean definitions are read in, of course, if it's XML, annotation, Java config. That approach is going to be different. In fact, with Java config, technically speaking, the Java definitions aren't so much read as the config class is parsed, and it sort of takes a look at the @bean definitions to figure out what bean to call it and what class is going to be returned and so forth. The more interesting part of this, though, is that after the bean definitions have been loaded and they've been indexed, a special bean factory post-processor bean or beans will be invoked. And the purpose of bean factory post-processors is to have the ability to modify definitions in a variety of ways pre-instantiation. Let's look at that a little closer. So here's an application context which has kind of internally what we would refer to as a bean factory. The bean factory is actually the core class in Spring that knows how to order your dependencies so that it instantiates things in the right order, and then actually takes care of the instantiation and the dependency injection. It's the application context that sort of coordinates that with some of the other processes, like bean factory post-processor, bean post-processor, and so forth. So we would read in the first bean definition, and we would load 2 beans from that. and we would load in a second definition, and now we have 3 beans in the application context. Once the reading or the loading process has finished and we've kind of worked out our order, if any of the bean definitions that have been declared here happen to be of type bean factory post-processor, then those are treated specially. They get instantiated ahead of time, and then the application context actually calls the bean factory post-processor and passes the bean factory in. So he's basically saying, oh, I see that one of the beans that you've declared is a bean factory post-processor, so I'll instantiate it, and then I will call its post-process method passing in my bean factory. Again, the idea is that you have the ability to manipulate the bean definitions that are in the bean factory. Yes?
So what can you get out of while using a bean factory post-processor?
That's a good question. I've never actually tried to auto-wire anything in. It should be possible to directly wire things in through setters and so forth. I've never actually tried to do an auto-wire, so it'd be interesting. We'd have to run an experiment and see whether that would even work, because that would require things to be pre-processed and so forth. We'll see some examples where most of the time when we instantiate bean post-processors, we give it fairly static information, and I'll show you an example of a very common bean factory post-processor. Again, what's the purpose of a bean factory post-processor? It's to apply transformations, manipulate your bean definitions pre-instantiation. Anybody know of a common bean factory post-processor that is used in Spring quite a lot? Close. Property placeholder configure. Property placeholder configure. That's right. How many people have used property placeholder configure? You've been using bean factory post-processor. I bet you didn't even know it. Okay, that's what that is, bean factory post-processor. So here's basically how a property placeholder works. Do you guys use it this way? Or do you actually configure the bean factory or the property placeholder configure as a bean? The old way was that you would just configure the bean and reference its location. A more concise way to do that is to use this namespace scoped attribute that's part of the context namespace called property placeholder, and you specify the location of a properties file. So how does this work? Well, here's my bean definition, and notice that I'm using a pattern in my values where it's $ curly brace and a variable name, close curly brace. Well, that turns out to be a pattern that is recognized by this property placeholder configure, and essentially what it does is it goes out to this configured properties file, and it looks for a definition where we have this pattern. So we see db_url really maps to an actual path, which is the path to the database. So what happens with the property placeholder configure? It swaps out that variable pattern with the actual value associated with it that's found in that properties file that's been configured. Okay? So that's one very, very common example of a bean factory post-processor. Yes, sir?
How does that work with the Java configuration? Is that still a capability?
It gets a little more interesting in Java configuration only because of the fact that you're in control of more of the instantiation. So there's other patterns that can be used like Spring expression language and so forth. But nevertheless, you could actually use this mechanism to sort of wire in values if you wanted to. So you can use the @value annotation, for example, to wire in a property placeholder type configuration. And then you would use that value to then set your properties. That would be probably a better way to do that. All right? Question? Yes?
Is there any way I can override the properties in runtime by accessing the property placeholder?
So override the properties. So you're going to set a set of properties in a configuration here, but then at startup actually override them?
In the runtime, like if I want to change the DB URL, I want to inject the property from the Java code. Can I access that DB URL?
Couple of ways you can do that, I think, if I understand your question. Java config is a really excellent way to do that because you can use all of the Java API to do that. And so when you instantiate, rather than having some mechanism like we're using here to say the property URL, which is really calling the set URL method, and then we would set it to some variable, we can actually write some kind of Java code to actually do that for us. Right? So that would be probably the most rich way to do it. There's a few other ways. If you're using an XML style, there's probably a couple of other ways. In fact, I'm going to show you a little bit later using a bean post processor to override some defaults that are configured by Spring. So that would be another way that you could do that. And so we'll show you some pretty tricky ways to do that. Just depends on how you want to do it.
Will Spring update the values in memory because it has all these values in memory? Like instead of DB config properties, if I have more system properties or something, which I use within the app, and I want to update those values in the runtime.
So after the objects are instantiated? Well, the answer to that is it kind of depends. So let me back up a couple of slides, because the scope of where you can do those kinds of things is within the lifecycle. I'm going to slip a little over here to the slides so that I can walk through this, but essentially you might be able to do it here in the lifecycle, and you might be able to do it all through here, but once the object is quote-unquote ready to use, then it's kind of out of Spring's hands to be able to do anything unless you're using some clever mechanisms like AOP or something like that. So as long as the answer is, I want to maybe do it after it's instantiated and within the life cycle of maybe a bean post processor, sure. In fact, I'm going to demonstrate that a little bit later. Okay? All right. All right, and just really quickly, Bean Factory Post Processor. You'd say, well, where is the Bean Factory Post Processor? It turns out that when I used context property placeholder, as of Spring 1, that actually translates to a class called property sources placeholder configurer, which used to be referred to, and I still call it property placeholder configurer, but that's actually kind of a legacy class that's been replaced by property sources. Basically does the same thing, but has a little more flexibility, a little more richness. That's exactly, so you would use, there's an annotation, essentially, that's the equivalent of a property placeholder that would allow you to do that. Yeah. If you see me afterwards, I can show you basically what that looks like. All right, so just a quick review here in the lifecycle. So we're talking about for every bean that sorry, let me back up. We just finished the Bean Factory post-processor step, so now we've taken all of the bean definitions en masse, and if we've used the example of property placeholder or property sources configure, we've essentially gone through every bean definition before instantiation, potentially changed up their values using some definitions that are found in a properties file. Then, for every bean that's in the Bean Factory, we're going to iterate over each bean, instantiate them in the proper order, call their setters, pass in those dependencies that we need to pass in or properties. Then we go through a series that we call the before initialization, and after init. That seems kind of complex. You might say, well, why are there so many steps? Because there may be some different things you want to do. You may want to post-process before the initialization phase, after the initialization phase, and so forth. And initialization is kind of this nice little easy-to-access step that you can get access to with a simple attribute on your XML configuration or a simple annotation in your Java application, whereas bean post processors are kind of a special class you have to instantiate. So this central point, initializers, that gives you quick and easy access to just say, after the bean's been instantiated and properties have been set, call some method that I've annotated or marked as an initialization method where I can do additional processing. And what Spring allows is processing before you call the method, processing after you call the method. Sometimes you want to wait until the very, very end, just before you release control of the object, and then we will go ahead and do some special processing. So there's two types of processors then. Well, actually, I should back up. I'm going to show you the simplest bean post processor, which is called the interface is called bean post processor. There's actually several bean post processors that extend that allow you to insert processing in a number of different places. There's one called the instantiation aware bean post processor and so forth. I don't want to get into that too much here. I really want to just focus on this, and if you understand the basics of what this does, then you'll begin to understand what those other bean post processors can do as well. So again, two categories, I might say, of the bean post processors that we would specify. I really want to focus on the actual implementation of bean post processor because that's where some really powerful kinds of things can be done. So bean post processors are another important extension point in Spring that allow you to change the bean instance in some way after it's instantiated. Okay, again, that's the big distinction between bean factory post processor and bean post processor. Bean factory post processor, you're manipulating definitions before instantiation. Bean post processors, you're manipulating the actual instance in some way. I'm going to show you a couple of different ways that that happens. This is huge. This is one of the major mechanisms that Spring uses to give you access to a whole array of capability that I'm going to show you. And once you understand how this works, you can start taking advantage of it yourself in a variety of ways. And that's where we're really going to start getting into the patterns. So the interface on a bean post processor is really this. Now, notice that both methods have the same signature, basically, where it takes in the object itself as a bean. Why is it an object? Because we don't know what instance is there. So we're going to pass in an object, and we're going to pass in its bean name. Then we're going to return an object. Any guesses what that object is?
The modified object.
The modified object. Good. Excellent. What did I do with them? I moved them. Where'd that come from? Got one for you. Excellent. Yep, it's the modified object. Now, the question is, how might we modify that object? That's where things get kind of interesting. I'm going to show you a simple type of modification where all I do is go in and change a value of a property. That's a fairly simple type of modification. Another type of modification I'll show you a little bit later is I can return a different object. So I passed in object A, but I returned some other object. Does that seem like that might break something? Yes, sir.
That's probably more useful in immutable object cases. Like, so if you're given an immutable object, like common in some languages or frameworks, then you have to modify it and return something like in a builder pattern or something.
There could be something like that. I'll show you a couple of cases where we do things even more, even richer than that. So what I'm going to do is return an object that's a proxy to the object that got passed in, and that proxy is going to insert a whole extra layer of processing. And that's another pattern we're going to take a look at when we get into the AOP stuff.
That proxy has the interface of the underlying object.
That's right. So the trick is, yes, you can do that as long as the thing you return has the same interface as the thing you passed in, which, remember what I said about casting? Why would you want to cast to the interface? Because you really don't know if you're going to get the object that you instantiated or some proxy to that object. Okay? Question in the back. Yep. So the question is, if you have more than one bean post processor and it's potentially generating more than one proxy, you're actually creating a proxy of a proxy in a sense. There is a way to, so maybe the deeper question is there a way to control which one happens first? The way that you would do that is that all of the Spring Bean post processors implement the ordered interface, and it's probably a good idea if you implement the ordered interface. Ordered interface requires you to add a property called order. So essentially what Spring will do is make sure that the bean post processors get called in priority order. So that's kind of how you control that. Okay? All right, so the reason I brought that up is because Spring has a whole array of bean post processors that are available out of the box. Some of them get enabled not because I configure a bean directly, but because I use one of these tags, context::annotation-config. Anybody use that tag? How many people knew that those are the bean post processors that got created? More importantly, you probably said, I'm using that tag because I want to enable at post-construct, or I want to enable at required, or I want to enable at auto-wired, or something like that. You may not have known that what that actually did was register 4 or 5 bean post-processors. So you get kind of a freebie. You have one tag that configures up what would be called the most common bean post-processors. Each one serves a different purpose. So they all get registered, and based on their particular processing rules, they would determine how to take a given bean and change its characteristics on the fly. Okay, so that's essentially what's going on there. Now there's some others that you can configure manually. One that you might end up using more manually is called the persistence exception translation post-processor. That's a really long name. Spring likes long names because they're very descriptive. What that essentially means is that I can post-process a bean and intercept exceptions that are related to persistence that are typically checked exceptions. So if you're using JDBC, checked exceptions would be the SQL exceptions, right? If you're doing Hibernate, then Hibernate probably would throw unchecked exceptions. But what that translation post-processor does is it adds a proxy that intercepts all of those kinds of exceptions and translates them into the data access exception hierarchy that's provided by Spring, which is a pretty rich and expressive set of exceptions. So that's one you would have to actually register by hand. There's no simplification. You would just have to register it yourself, okay? But I mainly put this list up here, not so we could go through every one of them, but just so you are aware that Spring has a bunch of them, and they're provided kind of, some of them come out of the box for free, so to speak. You just one simple one-line configuration, and they're now configured up and available. And I'm going to demonstrate that here shortly when we start up our first demo. All right, so just to kind of summarize the life cycle of what happens, regardless of the life cycle of the configuration approach, we would have a bean detection phase where we would discover the bean definition. We would process that definition through what we call the bean factory post-processor phase. Then, depending on the instantiation type and so forth, we would instantiate it, dependency inject it in its appropriate way. And then we would run the bean through a bean factory post-processor. The main reason I put this slide up is so that you are aware that all of the 3 types basically support the same lifecycle processing, although they each kind of approach that in a different way. Okay, so that's kind of nice to know. If I use Java config, I can rely on the fact that it's going to go through a bean factory post-processor phase and a bean post-processor phase. If I use annotation configuration, the same thing is true in XML configuration. So that's kind of nice to know that works that way. So regardless of what approach you use, everything I'm teaching here is still appropriate. All right, it's time for a demo. You guys ready for a demo? By the way, I did upload my slides. So if you have access to your registration account or you have the USB that was given to you, you should have access to the slides as well. There will be some minor changes that I made that will get uploaded probably tonight, and then they'll be available tomorrow for you guys to grab. All right, so let me go through a couple of quick demos here in the platform. I've started with a really basic definition. Now, I've got some to-dos, and the reason I put the to-dos in is because as we're going through, I will probably forget to do something if I don't put a to-do in to remind me to do it. So I just wanted to put them up there to remind me, oh yeah, I need to do this step, so I don't skip a step and something like that. So what I've done is I've created just a simple Spring project, and what I've done is I've defined a simple bean. There's nothing really fancy to this simple bean. It's just a bean that has a logger, and I'm going to use some initialization methods that I'll expose to you here in a minute. And those methods are there. There's no properties. There's nothing I need to set on it, so I'm just going to instantiate it. So if we look at this class, this simple bean definition, this is the most basic bean definition you can get, right? It says what class to instantiate? Simple bean. What do I call it? Well, I chose to call it simple bean, but I could call it foo, cat, dog, whatever I want to call it. What dependencies? What dependencies do we have here? None. Right? So we don't have to actually declare any dependencies. So then what I did was I implemented a really simple main runner. And by the way, I'd encourage you, if you ever have a few minutes to try this, this is very instructive. If you really want to know what's going on in Spring, use a pattern kind of like this, where you instantiate the application context referring to your configuration approach, whatever that is, and then you go to the application context and invoke this get bean definition names or get bean definition names. What that returns is an array of string that you can then iterate through as a collection of different bean names that are loaded in the application context. What can you do with the bean names? You can go back to the application context and do a get bean on it. So essentially what I've done here is I asked the application context, tell me every bean name you know about, and then furthermore, for every bean, go to the application context, get the bean, and I don't want to cast it, I'm just going to treat it as an object, and then I'm just going to ask the class, what is your class name? And I kind of took the simple approach, so it's beaninstance.getClass.getName. So I'll see the full class name, or I could have done get simple name as well. All right? So all that does is when I start up my application context and run this main program, it's going to list out every bean that it knows about, which is going to help me see what happens as I start adding some of the lifecycle tags into the bean XML configuration, or Java config if you're using Java config. All right, so here we go. Let's go ahead and run this guy just as is with one bean definition. And what we'd expect to have happen is, let's do this. What we'd expect to have happen is there's a little bit of a, kind of a preamble. That's just logging information provided by the Spring application context. What's more interesting here is that I see a list where it says loaded beans. The bean name is called simple bean, and the class is called simple bean with its class package prefix. Okay? So what we'd expect happens in that I have registered this particular bean, and so I would expect to see exactly one bean defined. All right, so let's go in and do some manipulation here. Oops. All right. So the first thing I'm going to do is I'll go ahead and just add an init method, because what I want to do is I want to instantiate that object, and during that phase of the life cycle, I'm going to call an init method where after I've instantiated it and called it setter, I'm going to do some special initialization, which is in this case, I'm just going to log out that, hey, I called the init method. So the way to do that in XML, anybody know? Init-method. Okay, you guys know you can do this, right? Init method equals, and where's that list coming from? It's just introspecting the class, and I want to call an init method. That's the method I set up on the class. Okay? So now let's go ahead and run this class again and see what that did. Notice that we got an info message right here that says an init method called. When did that happen? Before I listed my beans, right? Let's go back and look at our code and see why that is. Because in my code, when did I print out my list of beans? After the application context returned, right? When did the init method get called? During the startup of the application context as it's instantiating the simple bean. Does that make sense? Okay. Hopefully it does. All right. Not losing you, am I? All right. So let's do a couple more things really quick. I'm going to enable the annotation config. So that's just context::annotation config. Okay. Now let's see what that does. Wow. A few more things happened. First of all, in the red block here, notice that it says a post-construct method called, an init method called, then my loaded beans. Well, how many beans do I have now? I've got a lot more than just that simple bean. Where did those beans come from? They came from the fact that I registered that context::annotation config. Okay? And you can see that the beans that I referred to earlier, the configuration annotation bean post processor, auto-wired bean post processor, required annotation, all those got registered as a result of that one tag. Okay? Furthermore, if we look at this class again, this simple bean, we'll see that there was a method, and I don't want to get too far into this because of the time that we have, but I did refer to an init method using XML, but I also annotated a class with @postConstruct. And there's a bean post processor that knows how to intercept the post construct annotation and actually call it at the appropriate time. And we can see from the order of this that it called the post construct method before it called the init method, in case you're wondering what order those things happen in. You can have both. You can have an init method and a post construct method. Just realize that the post construct method will always be called first because it's actually a bean post processor implemented using a post process before initialization. Okay? That makes sense? All right. Hopefully so. All right, so let's quickly add a Bean Factory post processor. What I've done is I've defined really simple Bean Factory post processors. All I want to do is I just want to get a picture into the life cycle that we're going through. Right? So this is kind of a neat way to just go through and see what happens at different phases of the life cycle. So what I did was I wrote a Bean Factory post processor I called Simple Bean Factory Post Processor, which implements the Bean Factory post processor method, and in particular requires me to implement the post process Bean Factory method. And all I did was I just wrote a logger message that said, hey, I'm in the post process Bean Factory method. Okay? So what I'm going to do is I'm going to register that as a bean. Let's see, Simple Bean Factory Post Processor. You guys know you can do that sort of thing? Control space. Worth the price of admission to Spring One right there, right? Yeah, that is largely Eclipse. I'd like to take, there's some credit that should be given to the STS team because this is actually the Bean definition file. But if you were in a Java class, you can do the same thing. Okay, so I really do need to give props to the STS team who has really done a great job with putting together a tool that makes it really, really easy to do this kind of stuff in your XML. But in Java, you're going to have full access to that in virtually any editor, you know, that supports code completion and that sort of thing. So anyway, that's kind of a nice little feature. All right, so just by declaring the Bean Factory post processor, let's see what happens now. Any guesses as to what's going to happen when I start this thing?
It's going to print out.
Absolutely, it's going to print out. What's it going to print out? That's the real question. All right? Well, let's see. I don't know if you guys can read this. The text is a little bit small, but notice about 5 lines, 6 lines down, it says info in post-process factory, in post-process Bean Factory. Okay, that was the first thing that happened. Next, pre-instantiating singletons. Next, a post-construct method called. Next, an init method called. Then we list our loaded beans, which always is going to happen at the very end of that once I've instantiated everything and returned from my creation of my application context. Okay? Yes, sir?
Is there a way to clean up, get rid of those beans once they're no longer needed? They're only needed for initialization.
So what's the question again?
Could you get rid of all those annotation processor beans? Or the garbage collector? Now that they're not needed anymore.
I'm not sure. Yeah, I mean, the thing is that they are created and managed by Spring. Would it make sense to create them as prototype and throw them? I haven't actually tried that. Usually, here's the deal. People are going to write hundreds or more beans that get created by Spring. And there'll be 5 classes that are part of this lifecycle startup. So could you come up with a strategy for cleaning them up? Maybe, but would that be of any benefit? Yeah.
The question is that when you have a lazy initialized bean,
Yep.
don't you need this one?
Bean Factory post processor, no, because the Bean Factory post processor would actually be processing the definition even if it's lazy. But in answer to your question about Bean post processors, yes, you have to keep them around, especially if you have singletons or lazy, because they actually get called. So anybody know about singleton scope? Sorry, I said that wrong. Prototype scope. So for prototype scope beans, they actually wouldn't get instantiated until you did a get bean type operation, right? So that triggers the instantiation, dependency injection, bean post-processing, and all that stuff. So it's generally not a good idea to toss those away. But if the question was a bean factory post-processor, in theory, but I don't think it would buy you much. Unless you have a bean factory post-processor that's just gobbling up memory for some reason that I can't think of. Right? All right, let's move on. One more thing. I'm just going to throw this last one on here. And again, this is just kind of a fun little exercise if you've got a little time to play around with it and see what happens when you declare these beans. So we'll do bean, class. This time it's a simple bean post-processor. Gotta love that. All right, so what happens here?
Prints out.
Excellent. You're on your way to getting your second USB right there. All right. So let's see. Now we've got a let's see, let me back up. So pre-instantiating singleton, so that's where let me back up even further. So we're in the post-process bean factory. That happens before you instantiate. Then you see that it says pre-instantiating singletons. Then the next thing that it says, if you go down a couple of lines, it says in post-process before initialization for bean, simple bean. Well, where did that come from? Should have shown this to you ahead of time. All I did was I took the bean name that came in and I said, I'm post-processing this particular bean. That make sense? And I do that twice, once for the post-process before and one for the post-process after initialization, just so you can see when each takes place. So then when you look at this output, you can see that it says pre-instantiating, in post-process before initialization, post-construct method is called, which is actually another bean post-processor, post-process before initialization. An init method's called, post-process after initialization, and then I list out my beans. So you can kind of see the order of how things get started up. Yeah?
How come your post-process didn't process all the spring beans?
How come it didn't post-process all the bean post-processors? It's not going to post-process post-processors. Right? That would be, there are some caveats to that whole thing, right? Because you could get into some pretty ugly cyclical sort of things in terms of post-processing. So it won't post-process other bean post-processors. Order, so at this point, it's just kind of order of bean definition, but again, if you wanted to use the ordered property, you could specify what is the order that those get called. All right, one last demo, and I'm going to ask you again, take a shot at what happens here. So what I'm going to do is I'm going to define a second instance of that simple bean because that's the only Java class I have. So we'll go bean. Now this time I'm going to give it an ID of just SBB2 or SB2. Class equals SB. Oh, that one's not quite so easy, is it? Simple bean, there you are. Oops. All right, so I'll ask again, what's going to happen? And the answer is not print something out. Okay, so the real question is, how much are you going to see? So how many times are we going to see the bean factory post-process print out? Once, very good. How many times will we see my special simple bean post-processor print something out? Excellent. Yes, sir. Oh, you're absolutely right. Why 4? Because there's a before and an after. Thank you. Good catch. I don't want to fire it at you, but how about that? I should have been in baseball. All right. So let's run this and see if he's right. All right. So post-construct, let's see, let me back all the way up. Ooh, this one's got a little longer. So in post-process bean factory, so here we are. Then pre-instantiating singleton, so now that's going to start the life cycle for every bean. Now, watch carefully what's going to happen, because yes, we're going to call the bean factory post-processor twice, but in what order is it going to happen? Okay, that's a critical thing to watch. So we're in post-process before initialization for being simple bean. Then we're in a post-construct method. We didn't say which bean. We're in an init method. And then we're in the post-process after initialization for simple bean. Then what's next? We're in post-process before initialization for SB2. Then we're in the post-construct method. And then we're in the post-process after initialization for SB2. So you kind of see how that life cycle flows, hopefully. Okay? Oh, why didn't the init method get displayed on the second bean? Anybody know? I didn't define it. So if I did this, right? Then yeah, it would display it. Well, the annotation was already there, and I was already using the common annotation bean post processor, so I got a freebie on that one. But because I was also using the XML approach, I had to explicitly say init-method on the second one. That's why it didn't show up. Yep?
How about order? How about if you care about order?
The order of the bean creation? Well, I mean, the simplest way to do it is I could just take this bean definition and put it up here. That would be one way to do it. Or again, I could use the ordered, or I could use a couple of other things. There's a couple of other things I can use to do that. Depends on or something like that.
Anything with the Java annotation? The order in the class?
Well, in the Java annotation, you just set the order, you'd call the set order method.
Oh, right.
Then it would be order of declaration. You'd probably want to try to make sure they weren't equivalent. There's some on the ordered API, there's enumeration like highest precedence, lowest precedence that are like, the highest integer and the lowest negative integer and that kind of thing. So you can kind of force something to be the first thing or the last thing that's called. So you can use that mechanism to do that if you want. Yep.
One question, was this feature available in 2.5 and 2.8, or is this something?
Almost all of these features have been available in 2.5. The one, I'd have to double check the common annotation bean post processor. That might have actually got added in Spring 3 when most of the annotations, there were a number of annotations that were supported in 2.5. Most of them related to Spring MVC. That was when we kind of put our toe in the water with annotation-based config. I believe that the common annotations got added in Spring 3.
But these post processors are always available in 2.5, 2.8. You don't really have to build your own custom.
Actually, in 2.5, I'm not sure what got configured. You'd have to kind of do the same experiment and see what gets configured up. The bean configurations that are the bean post processors that get configured have changed a little bit from one version to the next as the architecture has evolved. So the best thing to do, I've not seen any documentation that says these are the beans that get configured. In fact, I've been teaching Spring since Spring 3.0, and it was one set of beans, and I taught it, and I never went back and double checked. Just recently, I did this check, and I found out that there's one bean that was removed and another bean that was added, bean post processor, and so it's changed a little bit, and I never noticed it. Okay, one last question.
Is there an equivalent of post-construct in XML configuration?
Is there an equivalent of post-construct in what?
In XML configuration? Can I define?
Yeah, the equivalent is the init method. Basically, they do the same thing at roughly the same point in the life cycle. One is an XML way to do it. That's been around since the beginning of Spring. That was the way. There was actually another way they did it. Anybody know what the old way to do that with Spring? Initializing bean. Yep. You're a Spring pro. Yep. Initializing bean, and there was a disposable bean that was kind of the destruction side of it as well. By the way, there's a whole destruction phase that's supported as well, which is the destroy dash method in XML, at pre-destroy annotation, and disposable bean would be the old way to do that. All right. Let me forge on, unless there's any burning questions. I'll try and answer any unanswered questions at the end. Otherwise, I'm going to be standing between this presentation and dinner, and I would not want to be between you and dinner at 6 o'clock. So let's go ahead and get going here. All right. So just a reminder that this is kind of what we've looked at as this life cycle. So what I want to do is come back and spend a little bit of time talking about bean post-processors and show you one thing that you could do yourself with bean post-processors. There's probably a lot of use cases you could think of. I was thinking about this some time back, and a question came in from somewhere, I can't remember where, and it made me think about it a little bit, and I kind of came up with a bean post-processor example that was based on it, and we'll see if it makes sense to you. How many people have used Spring MVC? Most of you? Okay. Spring MVC with annotations. Still lots of hands? Okay, as of 3.0 or greater. Okay, so this is going to kind of make sense to you maybe a little bit then. Has anybody used exception resolvers? A few of you? Okay. That's kind of where we're going with this next section, is I'm going to show you a little bit of what happens in Spring MVC, and we're going to use an exception resolver strategy to change the order of how the exception resolvers get called. So just as a summary then, Spring provides post-processors that will perform initialization. That's an example of that is the post-construct method that we've already taken a look at, which is exposed by the common annotation bean post-processor. There's also some validation that you can do, declarative validation based on annotations called JSOR 303 annotations. Or validation. There is a special bean post-processor called the bean validation post-processor that will do that kind of validation. There are some post-processors that will add behavior associated with async. So I think that was the substance of Jürgen's talk in the prior session, was how you can use annotations to declaratively add functionality like at transactional, at async, and a number of others, at cacheable. So how do those happen? Well, you can actually add behavior, and we're going to take a look at that a little bit later, and that's really one of the more powerful features of Spring, and it's actually something that you can take advantage of yourself, and I'll show you how to do that, assuming we have time to get through all of this. It is, wow. All right, so here's the problem that we're going to state. Spring MVC provides a number of exception resolver strategies out of the box with the MVC annotation driven tag. The question is, well, the processing is pre-ordered. In other words, it's going to access those in a certain order, and the question is, how do I change that? Well, there's two ways I can do it. One is I can manually configure all three of the exception resolvers which implement the ordered interface, and I could manually set the order property. But that seems kind of like a heavyweight solution. What if I want something a little broader, something a little more flexible, that would allow me to kind of have a flexible mechanism for doing that? The answer is I could write a special bean post-processor to do that. So let's look at this another way. When I configure MVC annotation driven, there are three exception resolvers that get registered, and they're processed in this particular order. First, the exception handler exception resolver, which looks for the add exception annotation, then the response status, exception resolver, and so forth. So that's the order that it's going to define, and I'll show you that that's the order. That's what their current order property is set to. So they're automatically registered. The order is the order they're consulted by the dispatcher servlet when it's handling exceptions is this order, and the question is, what if you wanted to change that order? So that's the problem we're going to try and solve. Okay, anybody tried to do that before? Just out of curiosity? All right. So the basic process would be something like this. I might implement a bean post-processor. What this is missing is the all-important implements, I just noticed. Got a little syntax error here. So I declare a class exception mapping bean post-processor that implements the bean post-processor interface. That's going to require me to implement at a minimum, well, both of the methods, but what I'm going to do is use the post process before initialization, and I'm going to write some logic that essentially checks the bean and says, is this bean an instance of exception resolver? And if so, then check to see if an order property has been defined for that particular bean by its name, and then if so, change the order property to something else. Okay, so I can actually intercept an object. And somebody asked me earlier, how can you intercept and change properties that might have been set? Well, this is what we're going to do with the exception resolvers is Spring has predefined what the order of those to be consulted is, and I'm going to go in and use a bean post processor to intercept those objects as they're created, change their property based on some declaration that I set up. Now, essentially how I've done that, just as, again, this is just an idea to throw out, is I've declared a properties attribute called exception resolvers. That's going to be my list of exception resolvers. And you guys are familiar with properties collection. It's just got the name and the value. Same as what you'd find in a property file. So I would need to implement the appropriate getter and setter. And I'm going to use the values that are found in that getter and setter to sort of take a look at the object as it's coming in. If it's an exception resolver, then is it one of the exception resolvers I've defined a property for? And if so, then find out what the order property that was associated and set it. Okay, that would be the logic. Now on the using side, or on the configuration side, I would have to declare my bean post processor, and what I've done is I've set the exception resolver's property and passed in values much like I would store in a properties file. So exception handler, exception resolver, I want that to have an order of 2. And the response status exception resolver, I want that to have an order of 3, and so forth. So by doing this, as the objects get created, I'm going to grab the object, say, yep, this exception handler, exception resolver, if that's one of the beans that I'm handling at the moment, then go find out what the order is and set that order to 2. Okay, so I can actually intercept those and change the values. All right, so let's actually just jump over to the IDE and take a look at that a little more closely here. So we'll move away from this project to this project. Let me start up my Tomcat instance, and I've already deployed this project. So what I'm going to do here is, once this starts up, I'll just open the home page, and we can see here that the order is predefined to have exception resolver, the exception handler, exception resolver, the order is set to 0, response set is set to 1, default handler set to 2. So that's the default that MVC::annotation driven sets. If we take a look really quickly at the bean post processor, I'm not going to spend too much time on the logic, but I just want you to see what I've done here. My exception resolver order post processor, as I called it, implements bean post processor, and in the post process before initialization, I just wrote some logic that implemented what I just described in pseudocode. Okay, you can take a look at that later if you want to see the details of how that's done. But essentially, all I'm doing is capturing beans as they come through. If they're an instance of exception resolver, well, really abstract handler exception resolver, special subclass, then I'm going to process that and I'm going to look to see if there's a property and set the order value if that property has been defined. That's all that's done. All right, so let's go back to our bean definition here. And what I'm going to do is I'm just going to uncomment the registration of that exception resolver. So at this point, that bean post processor hasn't been turned on, so therefore I'm not intercepting the beans. But if I were to do that, oops. All right. So we'll save that, restart the server. And then we'll go back and refresh this, and you'll see that the order has changed to the order I've defined. Right? I just kind of manipulated and changed the order on the fly. Again, how did that happen? Well, if we actually fire up or bring up the console, you can kind of see as it's going through the instantiation. Let's see if I can find that here. Yep. You see this block right here. Processing an exception resolver for bean, and you can kind of look at the name of the bean. So I've said, yep, I've got an exception resolver, and I'm setting the order to 2, setting the order to 3, and I'm setting the order to 1. So I basically just intercept them, said, yep, I found an exception resolver. I found a matching order property that was set in my bean post processor properties. Now I'm just going to use that to set the order property for that associated bean. So it's a way that I could intercept processing of my beans as they're started up, so that I've changed what Spring has done and provided my own definition of the order. Does that make sense? Okay? So again, really powerful feature, but that's not even scratching the surface on some of the things that we can do. So let me quickly see if I can get through some of the other things here. All right, some patterns that we're going to look at. I'm going to skip through the programming to interfaces, and I might even skip the demo on this and just let you take a look at the code for it, because I want to get through at least proxies and AOP. Templates kind of, has anybody used templates in Spring? You guys understand the basic template pattern, right? So Spring uses them all over the place, and the point I would make is there may be cases when that might make sense for you guys, and so that's probably one of the ones I would see as least usable, something that you would probably have the least need to implement, but be aware that that pattern is used throughout Spring, and it's one that you could use yourself to hide complexity and that sort of thing. So I'm going to touch on programming to interfaces because it really is a building block to proxies and AOP, and then I'll quickly touch on templates if we have time, and hopefully we'll have a little demo time as well. All right, programming to interfaces. So here's how this works, and I'll bet all of you guys have been doing this for a long time, so I'm probably not telling you anything you don't already know. Everybody kind of using this approach of programming to interfaces? Hopefully. Because everybody tests their code, right? Everybody says yes, and we're going to discover in a little while that it makes it much easier to unit test your code if you program it to interfaces, and I'll show you why really quickly. All right, so in this example, we have a JDBC account repository that implements account repository and transfer service impl that implements transfer service, but notice what object type we have a dependency on. Any implementation of account repository. Any implementation of account repository. That could be one that's implemented for JDBC, one that's implemented for Hibernate, one that's implemented for JPA, one that's a stub that I use for unit testing. Doesn't really matter. Okay, that's what we refer to as programming to interfaces. Now, it turns out this is a huge building block that Spring takes advantage of. So I would encourage you as much as possible, and if you're using Spring, you probably are finding yourself doing it naturally anyway, because it's just, at least for me, I found that it was one of the things I just kind of fell into. I saw the pattern, I recognized the value of it, started discovering the testability capabilities, and I just kind of fell into this pattern. More so than I did before, where it was more happenstance, but as I was doing more Spring development, I found myself doing this more. All right, so here's the benefits of programming to interfaces in a nutshell. Loose coupling, so more pluggable architecture, out-of-the-box components that support, well, I guess the idea here is that Spring has a lot of out-of-the-box components, but then you could plug in your own implementation. And I'll show you a quick example of that here a little bit later. Improved reuse, again, write once, use multiple places potentially if you write it correctly, and improved testability, which is a huge gain, really. So here's an example of, what is going on there? Huh. Oop. That's odd. All right. Oop. Don't move it. I got it. All right, so what this is supposed to show is a Spring box around these two objects, because what that's showing is that for a particular JDBC configuration, I might set up a configuration where transfer service has a JDBC account repository dependency injected in, because that's the particular implementation that I chose to instantiate. Or I might, wow, that's weird. All right, you're going to have to use your imagination here. There's a Spring box around this. I swear this worked earlier, so I'm not sure what's going on here with the presentation, but there's a Spring box around this, and it's designed to show that in another case I might use JPA instead, and that would work just as well because both JPA account repository and JDBC account repository both adhere to the same contract, and that's what transfer service impl depends on. But even better is the ability to plug in a stub, which really doesn't have any Spring associated with it, but you have the flexibility to plug that in and then unit test transfer service impl. So that's kind of the side benefit that comes from all of that. Now, in Spring, there's some things that you can do in the application context that are more related to certain interface contracts. So you can use a pattern like this. You can say, well, I want to do a get bean names for type. So I'm interested, for example, in all beans that implement the post-processor class. Well, you think Spring might be doing something like that internally and then using that as a mechanism to pre-instantiate certain objects? Okay, so that's an example of something that you could do yourself. If you have certain interfaces that you're looking for, you could say, I want all beans of a certain type, some interface that you've defined, and then you can do something special with those objects. Another thing that you can do is I can say I want beans of all type, which is going to give you a string, a map that is, in this case, what I'm doing is saying I want all beans of type exception handler resolver, or handler exception resolver, and what it's going to give me back is a map where I have the bean name and the object. So then I have all my objects of that type that I can do interesting things with, all in one.
Define a bean name.
Say again?
What if you didn't define a bean name?
If you didn't define a bean name, then Spring still gives it a name internally. So it'll just give you the internally defined name. It's kind of based usually off the class name. Yeah. Now, those are just APIs that are part of the application context. There's also another class called Bean Factor Utils that gives you some really nice flexibility for doing nested definition searches and ancestor bean factories and things like that. So, just be aware that that's a component that you can take advantage of, and Spring certainly does. And I'll show you some cases where it does here. Bean post-processor, Bean factory post-processor, we've already kind of talked about that. Platform transaction manager. Anybody doing transaction management in Spring? You guys are probably implementing one of the transaction managers. So data source transaction manager, JPA transaction manager, Hibernate transaction manager. Those are Spring classes that sort of provide a common API or a wrapper over the top of different transactional implementations. So those all implement one common interface, which is Platform Transaction Manager. So at the end of the day, Spring applications don't really care what implementation it is because they all have the same base class interface. And so you just plug in whatever transaction manager you want, annotate with that transactional, and you have transactional capability declaratively. Okay? So that's one of those features. Spring remoting, I'm going to show you an example of this here in a second, where we use this thing called the RMI proxy factory bean to take an interface and build an RMI proxy that kind of replaces the need to have stub and skeleton capability for RMI or other remoting technologies. Spring makes heavy use of this because in many cases it supports multiple view resolver strategies, multiple handler mapping strategies, multiple exception resolver strategies, which we've already kind of taken a look at. All right, so anybody use multiple view resolver strategies in their applications? Okay, so you declare multiple view resolvers. Did you use the order property to specify their order? Okay, again, Spring takes advantage of that and it says, okay, I'm going to instantiate a set of view resolvers and then I'm going to consult them in some particular order, either the order of instantiation or the order you set that property on and so forth. So there's a lot of that kind of stuff going on in Spring. That's kind of my point of this slide. The one I want to draw your attention to is one we're going to look at in a little more detail. How many people are using Spring Security right now? Ooh, great. Is anybody implementing some custom security components? A few of you, like a user detail service? Okay, so you guys have probably already done this kind of a thing. So you're already doing what I'm talking about. Really quick, I'm going to give you a quick overview of Spring Security and just give you some ideas of some things that you can do. Big picture architecture of Spring Security is you have an authentication manager that handles the authentication process. It's a pluggable architecture that, guess what, all implements a common interface. So you can plug in different authentication manager strategies. On the other side, there are some components that are what we call interceptors that are implemented as a set of filters, servlet filters, that implement a common interface, and you can actually plug in a chain of filters that process your request in different ways with respect to security. And then there's another area which we call voters, which is a way that you can plug in additional access decision strategies. For example, you might say, well, in addition to being of the right role, they have to be able to, they can only access your application within a certain time window. So if you're within the time of 6 a.m. to 6 p.m., then I'll grant you access, but if not, then I'll deny access. So that's a component you could plug in as a voter. Okay, so that's kind of the high-level architecture. Obviously, a lot more to Spring Security than that, but that kind of gives you the big picture. Now, the other thing you might get from this is, gosh, it seems like a pretty complex architecture, something that would be very problematic to implement, but it's really not that bad, as I'll show you here in a second. Under the covers, there's a set of filters that are processing the request and performing different operations. Some perform authentication, steps and delegate to that authentication manager. Some are making access decisions. Some are handling different kinds of special exceptions and so forth. So all of that's kind of taken place sort of under the covers, and that's pre-configured up really quickly with this security:/HTTP tag. That's a namespace tag that's provided by the Spring security APIs. So if you have the Spring security libraries from that project in your class path, then you can go ahead and add those tags to your namespace and then declare Spring Security here. And security:/HTTP actually does quite a lot of this kind of configuration right here. All of that gets configured up behind the scenes automatically. I don't want to talk about that too much other than to say that they all implement this filter proxy interface, which is a servlet, both a Spring API and also implements a servlet filter API, which means that they can act as filter processing, if you're familiar with servlet filters. The nice thing about that is that you can simply plug any of those implementations in and they just sequence from one to the next, and you can specify the priority or the order that they're consulted and so forth. More interesting is the authentication manager architecture, because that's often one of the areas that folks like to customize right off the bat. One of the issues is that, yes, there is a JDBC user service that you can use out of the box, but it's fairly simplistic. Okay, it's a sort of a not very well normalized set of tables that are predefined, where there's a user table and a roles table, and then they kind of link them together with the user field. And so it's if you want to do anything special like add additional attributes for the user details, or if you want to add metadata related to the roles, then you have to kind of implement your own capability. So I took kind of a shot at trying to quickly throw up some different classes that are used in Spring, a sort of class hierarchy. Probably not 100% accurate or complete, but enough to show the point. One of the things I also caught was that provider manager actually has a reference, again, programming to interfaces, to authentication provider, not DAO authentication provider, but that's a small detail. The point of this is that if you look at the bottom section, user details and the user details service are two classes or two interfaces that are commonly implemented in custom ways. And it's very easy using this programming to interfaces architecture to simply implement your own custom user details service and your own custom user details object. Okay? If you've done, I imagine a few of you have done that kind of a thing before. So it's very flexible architecture, and because everything is based on programming to interfaces, you just define your own user details object, your own user details service, plug that in, and I'll show you how to do that here in a second. So the user details class defines what are the required properties. Get password, get username imply that you have to have a password and a username property. Get authorities implies that you have an authorities property of some type. Now, Spring has some out-of-the-box implementations of this, but you can implement that any way you want. So if you implement the user details class, then you can extend that and add your own properties. That's kind of what that second bullet is trying to say. The demo that I have that I probably won't go through actually does that. So I take a user details implementation, I add to it an email property and a phone number property, and then I implement my custom user details service to go fetch that object from the database and populate it with the additional properties. And I also went to the trouble of creating a 3-table architecture where I have a user table, a roles table, and then a user roles join table, just to make it a little easier to set everything up. The user details service, again, is just a contract. It actually only has one method. Load user by username. It's provided a string username. You return the user details, which is an interface. So what do you do in here? You want to implement your own custom user details service with your own custom user details. You just implement this interface and provide the functionality that could do any of reading from a file, going to JDBC, using JPA, Hibernate, iBatis, MyBatis, anything you can imagine you can do here. LDAP, although we've got an LDAP plugin that already does that. That's where you're going to do a lot of the hard work. You're actually going to define your own strategy for how you get and create objects. Again, I don't want to get too much into the security stuff other than to show you that this is a classic example of how you can plug in your own implementations by programming to interfaces that are predefined by Spring, and then you just plug in and configure your own components. And in fact, we did that right here. So what I did was I defined a bean that is of type custom user details service. That's my implementation, where I've implemented this interface, load by username, and I've defined how to go out to the database and populate a user details object that I've personally defined. Okay? Now, in order to use that user details service, what I have to do is in my authentication provider, I just provide a reference to my user service. So I've now replaced the out-of-the-box JDBC one with my own custom user service. Very pluggable architecture, all because we're programming to interfaces. Does that make sense? Questions before we move on? I would do the demo, but we're pretty short on time. In fact, we're right at the top. So I want to quickly go through the AOP stuff, and then I'll probably turn you loose from there and answer any questions. Okay? I know you guys are getting hungry, so here we go. Proxy power. This is an important one. This is kind of one of the ones I was hoping to spend a little more time on and get into. This is a kind of a big topic, but basically the idea of proxies is this. A proxy is a stand-in for an actual object implementation. So a really simple way to look at that is we have a contract that's defined by an interface. I have an actual implementation that implements the interface, and I have a proxy that also implements the interface and delegates to the target object. Okay? And then instead of returning the actual target object on instantiation, I return the proxy, and the proxy kind of acts as a point of contact that can intercept requests and do all kinds of interesting things. And that's kind of one of the mechanisms that Spring makes heavy use of. All right, so some classic uses where it does proxy kinds of stuff is factory bean. So there's things like the RMI proxy factory bean, mbean proxy factory bean, and so forth. That's that remoting technology. Spring AOP makes heavy use of that, and I'm going to touch on that a little bit. Transactions, you guys are already making use of that because transactions actually make use of that proxy mechanism as well. And then one of the new ones, anybody using Spring Data? Okay, you guys are using that as well because that essentially, that functionality exposes an actual implementation of a JPA repository or a Redis repository or something like that by way of these factory bean classes. Okay, so you declare an interface and somehow magically you have an implementation that knows how to go to your particular repository and fetch your data in the way you would expect. That's all done by way of a proxy. Okay, it's huge. Now that's directly related to programming to interfaces. So most of these things, what you're going to do is you're going to define an interface, you're going to instantiate some object, and during the lifecycle processing, a proxy gets created, and that is the thing that gets returned. And so all the while you're programming and thinking you're talking to some implementation of the interface that you defined, you're actually talking to a proxy. And the proxy does that extra processing. And again, the classic case that I like to show is transaction, which I don't recall if I've got that one, but another one that is a good case of that is this remoting capability. So this remoting, the general strategy is that I have some basic implementation, we'll call it the transfer service impl that we've been talking about, that implements the transfer service. I expose a service exporter that basically provides the server-side marshalling capability. Then on the client side, I use the interface to generate a proxy using a proxy factory bean. And then I take that proxy and I plug it in. Now as far as this desktop teller UI component, it's talking to an interface and it thinks it's a valid implementation of the transfer service interface, and it is. But it's not one that you wrote, it's one that was created by the Spring proxy factory bean. Okay? That's the power of programming to interfaces and using proxies. This is kind of a quick configuration. I'm going to spin past this. Another one that's really important, and I'm going to use this to expose a pattern that you may want to take advantage of yourself, which is leveraging AOP. How many people are using AOP right now? Whew, wow. Okay, quite a few of you. Spring AOP or Aspect J? Spring. Okay, that's the easiest one to make use of. So I'm going to quickly go through this, and I want to use it as a mechanism to talk about how to use annotations to declaratively add your own functionality. So maybe you guys are doing that sort of thing, or maybe you're just using point cut expressions to apply them directly. But that's the basic idea. So there's a lot of different implementations out there. Spring AOP uses kind of an amalgamation of kind of its own proxying mechanisms with aspect J syntax, basically. And so we're going to use the annotations and some of the APIs from aspect J, but we're actually going to implement what we call the weaving process by doing what we call proxy-based weaving. That is, during the startup, we're going to create proxies that sit in front of the actual object where we take the method call and then pass it through our AOP functionality and then call our target functionality. That's essentially how Spring AOP works. All right, so a really simple example is this. I've got a simple cache class that implements the cache interface. And we see one method called setCacheSize. And we implement that method as well as adding a setDataSource. And then I have this property change tracker class that has a method called trackChange. And what I want to do is have some mechanism where I say every time a property is about to change, I want to report that that property is about to change. So how does that work? Well, I use the annotation that comes from aspect J to annotate the class to say, hey, this is an aspect. Then I annotate the method with something that's called a point cut expression. Point cut expression, which is just a fancy way of saying I have some kind of a selection expression that will target some set of methods on certain class of Spring objects. And in this case, I'm going to select all methods that have this particular method pattern of set star with one argument of any type and a void return type. Essentially what that says. So basically, we implement a class, put the annotations, with a little additional Spring configuration, this all turns into a very fancy proxying-based mechanism. So we can do that both in XML and Java configuration. The way we do it in XML is we have this AOP:\aspect_J-auto proxy. We point it to the property change tracker, and we say this class is going to be one of the auto proxying classes. So that's going to configure up a bean post processor that as the Java classes, the Spring beans are instantiated, it's going to examine the Spring beans to see if it has any methods that match the pattern that was described in that point cut expression. If it detects one, it says, let me create a proxy, and that proxy is going to intercept the request, route it through the advice, and then route it to the target object. That's, at a high level, that's kind of the algorithm that works with Spring AOP and proxy-based weaving. Java configuration, you can see the annotation-based equivalents of what we just did in XML. All right, so here's kind of the point to this whole thing, and this is kind of the nugget that hopefully you take away from what happens in Spring. So there's my simple object. That was instantiated, by the way, by Spring because I had a bean declaration. Spring will actually instantiate that object as part of the lifecycle. But then remember, I also have back here, this is a bean post processor being registered behind the scenes that's going to take every object and perform some kind of analytic processing. And in this case, it's going to say, do I have any methods on this simple cache that match the pattern that I've described with that point cut expression? If so, then create a proxy on the fly using a mechanism I'll talk about here in a second. And then it's going to apply what's called a method interceptor that's going to make sure that that request gets routed to the property change tracker before it actually gets routed to the actual target object. That's essentially, in a nutshell, what's happening with proxy-based AOP. Okay? Now, the important thing about all of this to make this work is that your proxy has to implement the same interface. And all calls are essentially, so in the bean post processor, that's a classic example of the actual simple cache got passed into the bean post processor, but what got returned from the bean post processor wasn't the simple cache, but rather the proxy that got created on the fly. Okay, so it's kind of a little bit of a switch up where we're returning a different object than we were given. Okay, that's done a lot in Spring. So you'll find yourself a lot of times when you're debugging, you'll be stepping through and you think you're stepping into the setCacheSize method, and the next thing you know, everything goes dark and you don't see any source code, and you go, what the heck just happened? That was you stepping into a dynamic proxy that was created on the fly because you annotated with @transactional or @async or @cacheable or any of the other annotations. And all of them basically implement this kind of a pattern. Now there's ways to debug that if you know what's going on, but just FYI, that's why that's happening. All right, let me quickly go to the next point. I don't want to spend too much time on this, but there's two proxying mechanisms that Spring provides kind of in its capability. By default, it will try to use what's called JDK or interface-based proxy. That is, if your class implements an interface, then the proxy will be created that also implements that same interface. However, not everybody implements classes that are based on an interface. So if you happen to have simple cache and simple cache does not implement an interface, then we use another mechanism that actually requires a third-party library called CGLib. CGLib will actually just create a subclass of simple cache, and that will become your proxy. And then it weaves in the extra logic. So two different proxying mechanisms, the result of which is pretty much the same. That is, that a different object gets invoked when you call it.
Is one preferred over the other?
One preferred over the other. I would say there's probably no disadvantage other than one is based on the JDK, so it doesn't require any extra libraries. So as a rule, we'd prefer that one just because of that. Now there's some debates. I think those have kind of died down, but there used to be some debates about which was more performant, and lots of different micro benchmarks that would try and show one being better than the other. Generally speaking, other than the way they behave, not too much difference in their preference. Yes?
One major disadvantage of the JDK proxy that we found was you just have to be aware that you're not calling the proxy when you're inside the class. For instance, transactional, if you're
Yep.
calling another method with
Yep. Good point. I talk about that in the class. That's actually true in both cases, by the way. It's subtle, and at first blush you'd say, oh, the advantage of using the subclassing approach is that you override the methods of the base class, and so therefore when you call methods interclass, you would actually get the proxy. But in reality, there's still two objects that get created, and it has to do with the lifecycle. So it turns out if you want to get around that problem, there's a couple of strategies for that. One is you just refactor, which is both the easiest but probably the least desirable. And then the other approach would be to use like a load time weaving or some other approach. Yeah, that is a limitation of Spring AOP, truly. Yep. Okay, really quick. Here's what I want to get to. Lots of different ways to specify point cut expressions. One of which is we can say, any method called send that begins with send takes one argument of type string. I can say any method, this is using packages, so I'm saying any method in any class that's in some kind of a package structure that has rewards and restaurant in it. Or here's the interesting one. Any method that's annotated with this particular annotation. Okay, this one's kind of cool because I can say, essentially, I can wildcard the pattern, say any method with any return type and any number of arguments in any class anywhere that's in my Spring Beans that happens to be annotated with an annotation that I decide. So now think about all the places that you might use declarative type behavior, at transactional, at cacheable. You can imagine how those sort of things work. So what if we had a use case where, in fact, that's basically how transactional works in a nutshell. So when you do TX::annotation driven, basically it's a bunch of AOP functionality behind the scenes that weaves that up for you. Okay, it essentially looks for methods annotated with that transactional. This is, again, the proxy, but we've already kind of looked at that mechanism. So let me quickly get to what I call giving meaning to annotations. You guys all know that annotations do what in Java code? They're nothing but a marker, right? They don't have any functionality associated to them inherently, right? What gives annotations meaning is some additional functionality that knows how to look for them and apply the appropriate functionality. So at transactional gets behavior because you register TX::annotation driven. At cacheable gets meaning because you register the appropriate bean post processors and so forth. Well, in this case, the pattern we're going to use is I'm going to say, I want to selectively perform some audit operation within an application using a marker that might be an annotation. So what's the process? I create an annotation. Don't even have to give it any functionality or any properties. I just create an annotation. Then I define an AOP before advice to capture the appropriate the appropriate information. And then I write a point cut expression that selects all cases where that annotation is created or exists, and then apply the advice. So quickly that looks like this, and then I'll leave you with this particular thought. We're going kind of long here. Apologize for that. All right, so here's my JPA order repository. So let's say on certain methods where I perform saves or deletes, I want to audit those. That is, I want to grab some information related to who did it, what it was before, what it was after, and that sort of thing. I could simply define an auditable annotation and annotate the methods that I want to mark as auditable. Okay? Then, and you see that all I did was declare an interface, an annotation using the annotation API that was introduced in Java 5. And all I've done is say, I've got an auditable annotation. Auditable annotation. Okay? Nothing else needed there.
Don't you need runtime scope?
Yeah, okay. So there's a couple of other things I have to add to it that include, like, does it actually get added to the debug symbol or the class compilation? You're right. There's a little more to it than that, but yep, you're right. I think by default it actually picks up some of that characteristic anyway, by default. But yeah, you're absolutely right. You need to decide, like, what's its scope and that sort of thing. But in essence then, all I do is I say, all right, here's my before advice. And my before advice is looking for this auditable annotation, any method in any class that has any number of arguments, well, any return type on any method with any number of arguments. And then in my particular do audit method, I have some code that does whatever I need it to do. Okay, I'll leave the details of what you would do there too as an exercise for you guys, but that kind of gives you an idea of the steps that you would need. So really quickly, you define an annotation, you write the point cut expression, and then you annotate your target methods, and then you just configure everything up as you would need to, as we talked about earlier, and you now have some auditing functionality. Now I have the example code. Again, you can download that, unzip it, and take a look at it, but that gives you kind of an idea of the kind of thing that you can do with annotations. And it turns out to be a very powerful mechanism where you can just simply define an annotation, drop it in, and suddenly add extra processing functionality based on the location of that annotation. So that's what I mean by giving meaning to your annotations. All right.
So you're using the AOP, the aspect module to...
The aspect actually gives the meaning to that, and that's right here.
Yeah.
So that's really in the do audit. It's do anything you want to do in there. That's your pre-post processing, and you can either do before, after, around, anything you want there. Right? It's huge. This capability is huge in terms of what it would enable you to do. Okay. So I would demo that, but again, I'm standing between you and lunch or dinner right now, so we'll kind of spin through that, and we'll use the time probably to answer questions. Templates, I think, are fairly self-explanatory, and a lot of people said that they've already used it, so let me just quickly get to the conclusion, which is that Spring, obviously, as you've seen, is much more than dependency injection. While it does give you centralized lifecycle processing, it really just enables a lot of things, which include taking advantage of programming to interfaces, creating proxies, being able to use templates and that sort of thing. And that's really in a nutshell, kind of what this session is all about. So hopefully you found something useful out of all that. I'll stick around a little longer and answer questions. Thank you for your indulgence. Thank you for staying late, and enjoy the rest of the show.